let's take a look at how to create a Xamarin Forms project. Open up Xamarin. I'm running this on a Mac, but it'll be the same on a PC, just minus the iOS solution. Click New Solution, and on the left-hand side, you'll see we have a lot of options, cross-platform, iOS, etc. If I just click through a few of these, you can see we get the classic iOS app, so single view, a tabbed app, that kind of thing. Same kind of thing for Android, and we can also create for Mac. For now, we're going to choose cross-platform app, and now in here we have two options. We can use Xamarin.Forms, or we can use a single view app. A single view app is actually just the cross-platform native app, and it's the classic way that Xamarin's done things. But this is a course on Xamarin Forms, so let's go ahead and select the Forms app and hit Next. We have to give it a name, so let's call this App 1, and we have to give an organization identifier, so I'll just put company in there, and so our identifiers on Android and iOS will be down here, com.company.app1, and this has to be unique in the app world. And then down below that, we want to target both platforms, and then we have some options. When we create our solution, we're going to create a shared code project. Now, you can either start off with a portable class library, or you can also use a shared library. There is no reason you can't have both in your project. The differences are the portable class library relies on the lowest common denominator. So if you declare something inside a PCL, it has to be supported on all of the platforms that you're targeting. A shared library, you can have conditional compilers in there. So when you come to compile for iOS, you can have a separate block of code that you look at instead of if you were compiling for Android, where you could look at a different block of code. And those are just simple if-else statements pertaining to which platform you're compiling for. For now, we're going to use a portable class library. Also, because a PCL is transportable, you can wrap it up into a DLL and you can give it over to other developers to use. You can't do the same with a shared library. Hit Next. It'll ask you for a name, a solution name, where to put it, etc. You can use Git for version control, but I'm just going to switch that off for now. You can also have insights and test cloud, but we're going to leave those for now. And when you hit create, Xamarin will run through and create the necessary files for you. And in your solution, you're going to have three main directories. One with your solution name, app1, and then an app1.droid and a .ios. And as you might imagine, the .droid pertains to Android and .ios pertains to iOS. And if I expand these three folders and we look at the top one without an extension on the end, this is the portable class library or the shared code project that is referenced by app1.droid and app1.ios. So if you click under references, you can see it's referenced there, and the same one in app1.ios, it's referenced there. If you right-click references, you can also edit them, and if you like, you can remove things or add things. It's up to you. So a few minutes ago, when I said you can actually have both a portable class library and a shared project, you would come over here to app1, you'd create one in here. I'm not going to do it now. And then, let me just close that. And then inside your .droid and .ios, you would create a reference to them. Okay. So, if we look at Droid or iOS, and if you're not familiar with the app world, they have different entry points into the app. On app1.droid, we have the main activity.cs. And if I look in here, I have this main activity. We'll get into what these declarations are later on. And I have a method in here called onCreate. And this is the first one that's fired when your app fires up. But here we have some specific code for Xamarin Forms. And this is saying I want you to load the application, new app. And it's much the same if we head over to iOS. In iOS, if we click App Delegate, we have the same here, finished launching. In this method is where we start to call the main code of our app. And again, we have our Xamarin Forms initialization and the loading of the application. If I click main.cs in the iOS project, there's nothing in there, so we'll ignore that for now. Pretend I didn't do that. Okay, so app delegate and main activity both ask Xamarin Forms for something. And that something is stored up here in app 1. So I'm just going to close these so we're not confused. And I'm going to double click app1.cs. And here we go. We have this class app that is referenced here and here. And inside this class app, we are creating what's called a main page. So this is the root of our application, the very first page that gets called. And inside that page, we have a new content page. And inside that content page, we have a stack layout. And this stack layout stacks things one on top of each other, horizontally or vertically. You decide which one. It gives you some options to position it. So vertical options, you have horizontal options too. So I can have, so equals layout options dot, and I can have center here, or I can have it at the end or the start. There is no right and left in this, so just bear that in mind. So I'm just going to shove this in the horizontal center. Don't forget your comma. And then inside that stack layout, we have a bunch of children. Now these children are the actual elements of your screen. So your buttons, your labels, your text fields, your entry text fields, list views, and things like that. In the next lecture, we're actually going to run this on some simulators for the iPhone and Android. And in that lecture, I'm also going to cover the installation of those simulators. So now we have a basic Xamarin Forms app. Let's run it in a simulator or on a device. Now, if you want to run your iOS app, you have to come down here to the associated directory, right-click it, and make sure Set as Startup Project is selected. And then up on the top left, we have a Play, a Debug, and an iPhone. You can either set it to Debug or Release. We're not going to worry about Release for a long time. And then the next menu will give us a list of devices. If you can't see any of these devices, then you need to open up Xcode on your Mac. And when that fires up, head over to Window, Devices, and in here you have a list of your simulators. If you want to add one, click the plus at the bottom, Add Simulator, and you can choose your simulator and your iOS version or download more simulators. But I've already got mine, so I'm just going to close that. And if we come back to Xamarin, you should then have a list of devices. And when I hit play, this is going to run it on my already open simulator. And magically, we have that bit of text that is aligned to the center of our screen. Now, it doesn't matter if you run this on an iPad or an iPad Pro, it'll always be aligned to the center. So just hit stop. And there we go. It's always aligned to the center because the content, the stack layout, is in the center of its container, and its container is the content page, which is the entire screen of your app. Okay, let's run this on Android. To do that, click app1.droid, right-click, and go to Set as Startup Project. Then that project will become bold, which means at the top we change to an Android debug menu. Now here we can manage our Android devices, but before we do any of that, we want to come up to the top of Xamarin, click Tools, open Android SDK Manager, and in here we need to start installing various appies and Android versions, because obviously we can't have an emulator if we don't have a system image for Android. So I've already got 501 installed, and I should have 403 installed. A general rule of thumb as a developer, and I'm saying this at the start of 2016, is that your minimum target level should be Android API 15. If you go below that, then you might start running into problems with compatibility, and it's really going to compromise your app's chances of running well on future devices. So the way you set a minimum version is you go to app1.droid, you double click it, go to Android application, and in here we have a minimum Android version. And mine's set at 15, and I think Xamarin does this automatically. Then you set a target, so it's going to build for this target. So I have to make sure I have API level 23 available. So if I scroll up, got 22, 20, I appear not to have 23. So I'm going to build this for 21, which was Android 5 or Lollipop, and click OK. This target Android version means that it just builds for that, but it will run on Android versions higher than that, so don't worry about that. And click OK. Come back to your SDK manager, scroll way down to the bottom, and we have to select our Android support library, our Android support repository, Google Play services if you're going to be using ads in the store and things like that. Let's see what else we have here. We can have our Xamarin installer. This speeds up your emulator experience. So let's select that, and I'm just going to install those packages. Let me switch off API 23, leave that on. Okay, install 5 packages. And once you've done that, come back, let me just click that, come back to this tutorial, and we'll be ready to install our simulators. Now, there are a few options for your Android simulator. The first one is the standard option, which is the normal Google simulator, which is slow as heck. Don't download this because it is hellish to work with. Your option 2 are various third-party services that work pretty well. Your third option is to use Xamarin's own Android player, because they identified that Android was so sluggish, they had to make their own. So search for Xamarin Android player, and eventually when my internet works, I think I can code faster than my internet can download text. Finally loaded. So go ahead and click that link, and it will take you to xamarin.com/Android-player, and then download that for your OS X or Windows or whatever it is, and when that's done, come back to this tutorial. So let's install that downloaded file. Oops, click that twice. Click continue, da-di-da-di-da, and it'll install it. It's quite a small program. And once that's done installing, close it and then fire up the Android player. And then inside of here, we should have some stock images of the Google devices, so the Nexuses. So I'm just going to create a Nexus. Let's see, let's have an API 19 Nexus 4. So I'm just going to download that and install it. And once that's complete, simply hit New Device, and it should be created. Once it's created, head back to Xamarin, quit it and restart it, just to be sure that it picks up our simulators. So I'm just going to close this Android player, there we go, and I'm going to fire up Xamarin Studio again, and when I do and I open my project, I should have access to that simulator that I just created. So up in our debug menu, let's hit our Nexus 4 and play, and it's going to build it and then start up our device and run it on there. And there we have it. It's running on our Nexus. And just for giggles, I'm going to open it up on our iOS, and there we have your very first Xamarin Forms cross-platform solution loaded on an iPhone and an Android device. Now it's worth saying that you can just plug in an Android device to your Mac or your PC and run directly on there. There are no special permissions required or certificates to download, unlike with Apple. Alright, in the subsequent lecture, we're going to modify this screen a little bit, and what we're going to do is start separating out some code to follow our MVVM pattern. So, we have our Xamarin Forms solution, but everything inside our app1 section is all kind of jumbled together, especially in this app1.cs. We've got some declarations of a main page, a content page in here, and we want to start separating these things out. So in a previous lecture I talked about XAML, and that's exactly what we're going to do here. So inside app1, because it's the shared project and everything is going to use it, go ahead, right click, click Add, New File. And we want the top file, which is the top section rather, which is Forms, and we want a content page XAML. So there are two items here for content page and content view, and XAML allows us to use markup language, whereas the other one doesn't. It's purely code. You can do it both ways. There is hardly any difference, but XAML, in my opinion, is a better way to do it. And so we're going to call this class main page. And when you hit new, it'll add it to there. And immediately you'll notice we have a main page.xaml and a main page.xaml.cs. So one is the markup and one is the actual code to sit behind that markup. So in the markup is where we're actually going to define our various elements. So inside our content page.content tags, we're actually going to drop in our stack layout. And then we're going to give this some options. So the first one is vertical placement, and we're going to give this center and expand. And then we have to give it a horizontal placement, and again I'm going to do center and expand. And then what else do we need to do? We need to have an orientation because it's a stack, so it's either vertical or horizontal, and we will have this as vertical. I don't know why that's not auto-completing. And then because it's a stack of things, we need to have some kind of spacing between it. So let's say spacing is equal to 15, and there are no units on that. And I think that should just about do it for the stack layout. It auto inserts the closing tag for us, so just press enter and that drops it down some spaces. And then inside of here we want to start placing our elements. So let's have, what shall we have? Let's have two labels so we can see this in action. Let's say label, and we have to give it some text, is equal to label1. So inspiring, that, isn't it? And let's throw in another label, and again text is equal to label2, and close our tags. And then I think that pretty much covers it, so go ahead and save that XAML file and switch to your main page.xaml.cs. Inside here you'll notice there's just one method to initialize your component. But this is where you would store most of your sort of access methods for getting data out of other classes. So you would put it most here. And this is, again, sitting into the MVVM paradigm, is that most of our code is stored here, so we don't need to rewrite it across Droid, iOS, and Windows Phone. We're not going to do anything with it in this section, but in subsequent sections we're going to use it quite a lot. So we've created a layout, we have some code behind it. Now we need to get this layout into our actual app. So this app1.cs is where we have to find this content page and initiate it. So what we're going to do is simply remove all of this default stuff that Xamarin has put in for us, up to main page, and we say main page is equal to a new and app1 dot main page constructor. So save that, and now that should run with our new main page. So go ahead and hit play. Usually when I'm creating Xamarin Forms apps, I tend to develop for both platforms obviously, but I test more on iOS because it's a lot faster to use the iOS simulator on a Mac anyway. So there we go, we have our two labels, and I'm just going to stop that running and select my iOS as the startup project. It would be nice if Xamarin let you have both starting up, maybe in a future iteration. And I'm going to fire that one up and check that it runs. And there we go. Now the first thing you're going to notice is that iPhone has a white background and Android has a black background. Now these are defaulting to whatever is set system-wide in the respective operating systems. So be very careful when you're sort of specifying your text colors. Always select your background color too. Don't assume that you'll always have a light background or a dark background. So again, the rule, as with all software development really, is to test, test, and test again, and then give it to someone that can't use software and get them to test it, because they'll find the bugs for you. Okay, that pretty much covers how to separate all of the code into this MVVM paradigm. And in subsequent lectures, we're going to get a little bit deeper with this and look at things like list views and abstracting away database classes and that kind of thing.